I've got chat. I've got participants. Okay, good. Okay. So this is me. I'm Erik Gross. I'm a longtime nerd. Been programming computers for, well, 44 years. Leave me alone. I'm also a vet. I was in the Navy. Was a nuclear reactor operator and electronics technician in the Navy a very long time ago. And I'm the co-founder of the Tech Academy, the organization that puts on these free classes. Couple basic guidelines for the class. We have an assistant in the chat. So if you see Gracie interacting with you, she's our awesome assistant, and she's there to monitor the chat, answer questions, remove anybody who's being a problem, although that hardly ever happens. A couple quick things about the class. It will be challenging. We attempt to make this as easy as possible if you understand, and we do, but you might run into challenges as part of working through the coding we're going to do tonight. And that's just part of the learning process, is working through those challenges. So use chat as needed. And I'm going to watch chat as well and try to pick up questions as we go along. A real big thing to think with is that when we get to the point of tonight where we're writing code, you should ensure that you type the code exactly as it's written. One thing to know about writing computer programs is the misspelled word or missing symbol or even something capitalized that shouldn't be capitalized can result in errors in your code. Real important thing, make sure you're in a distraction-free environment so you can focus on the class and so I don't lose you. I want you to get as much as possible out of this class. Also, if you fall behind, it's totally okay. Keep listening and learning. You'll still learn a lot, even if you're falling behind on writing all the code, okay? And a lot of times people ask if this is recorded. It absolutely is. The video will be available later. We'll post it on YouTube, and you're going to get links to that. You'll also get the full code to the program we're going to make today. So you'll be able to walk away with a game that you can play and tinker around with on your own, and you'll be able to watch the full class again out on YouTube. Also, we're going to give you links to future events, free videos, other resources at the end of the event. All right, you all know how to use chat. I've seen that already, kind of found out where everybody's joining us from, which is wonderful. Basic agenda. There'll be a short explanation of the Tech Academy, and then we're going to write code. I'll try to answer questions during that as well, but time permitting, we'll have a brief Q&A session when we're done writing code. We'll go over some information about our boot camps, what we do, and there's a free gift for you at the end. Stick around. It's a pretty cool gift, okay? Whole class should take about an hour and a half. So, quick introduction to the Tech Academy. We deliver boot camps. And if you're not familiar, boot camps are intensive technology certification programs that are designed to prepare people for entry-level positions in tech. Typically, they'll last anywhere between 3 and 6 months, depending on where you go. They focus on modern, practical skills. It's just one of the 3 ways to break into technology. College, boot camps, self-taught. Boot camps is right in there. We've been offering thorough, budget-friendly, flexible, and trusted coding boot camps for over a decade at this point. We started at the beginning of 2014. Our programs are cost-effective, they're self-paced, they're fully online, and they're tailored. This is important. They're tailored for beginners, people that have no prior technical or coding knowledge. And we cover in-demand skills for the tech industry. Our boot camps are endorsed by phenomenal online reviews, and they're designed to fit around your personal schedule. There's a lot of flexibility, and we prepare you for a technology career with a really well-rounded toolkit. You learn a variety of tools. Nationwide, I don't know if you pay attention to this, but the average cost of a boot camp in America is around $13,500 right now. Ours are well under the national average. In fact, we have boot camps that start as low as $5,980. So they're affordable. And lastly, I just want to read our mission statement because it has to do with why we deliver these free classes, why we deliver the boot camps, everything about who we are. Here's our mission statement: to graduate entry-level technology professionals that excel in the basics of their field and thereafter have successful careers in the tech industry and whose actions raise industry standards and surpass client expectations. That's our mission, and our product is you working in tech. All right, let's get started. First thing we're going to do is cover a couple of fundamental terms. Some of you may be familiar with these already, some of you might not. let's just set a foundation. First is just what's a program? And I'll read it right here. Written instructions entered into the computer that make it perform specific tasks. But here's the thing I want to say. When you start to create programs, your whole use of a computer shifts 180. Instead of being forced to consume or use a computer's functionality as it's given, you get to flip it around and start to make the computer perform in a manner that you want. It puts you in control of the machine. It's actually pretty cool. So you do that by writing instructions in what's called a programming language. It's just a system of words and phrases and symbols that allow you to communicate with the computer and tell it what to do. Programming languages are what you use to make programs. Finally, coding. It's a verb, right? This is that action of putting those instructions in the computer. When you do that, you can say you're coding. The actual instructions are called code. You see those two terms, used a lot, okay? And finally, let's talk about Python. I'll let you read this for a second. It's a couple sentences. Python's awesome. It's a really popular computer programming language. It's been around for like 35 years, so it's very mature and stable. Couple nice things about it. When you read it, it really resembles just spoken or written English in many ways. In other words, it's easy to follow the logic of what the program's doing just by reading the Python instructions, right? Also, it's really versatile. You can build almost any kind of computer program you might think of with it, including games or mobile applications, websites, web applications. All kinds of things can be built with Python. So it's worth learning. In fact, it's one of the most popular boot camps. All right, now, here's the framework that we're going to use to teach you the basics of coding. And it centers around actually one of the most important things you could ever learn about programming. And that is, what are the fundamental parts of any computer program? Doesn't matter what programming language, doesn't matter whether it's made for a Windows machine, an Apple machine, an iPhone, an Android, if you're one of those people. Any program is made up of only 5 elements, and that's all. And so if you understand the principles behind these 5 elements, then it makes learning to program a lot easier. So we're going to cover that really briefly. The first element that any program needs is an entrance point. There needs to be a first instruction. In other words, you got to start somewhere, right? But that isn't just a duh thing. It's actually kind of vital for a couple of reasons. The first is, when you start up a program on your computer, the computer does a few things behind the scenes that help your computer be able to do the work that it's supposed to do. One of the most important things is this. Inside the computer, here's my computer, right? Inside the computer are little devices called memory storage devices. You've probably heard the term RAM. It means random access memory. It's just a little physical device, and you can store data in there. Now, there's only so much RAM available. Even if you bought a lot of it, there's still a limit, right? So when you start a program running on your computer, your program needs some space inside that memory device to store the information that your program is going to work with. And it's really important that no other programs on your computer get access to that and mess up the data, or your program will be toast. So one of the important things that happens with that first instruction being executed in a program is it signals to the computer that the program's on, hey, help me out and reserve a bunch of this memory for me. The other thing that makes it really valuable is this, and this relates to you learning this job of coding, of being a software developer. It's a really common thing to get a technology job and to be put on a team with a bunch of other people that are responsible for maintaining a really big program that's probably been around for a while. Happens all the time, I'm sure you can imagine, right? And when you, the brand new guy or girl on the team, are trying to understand this new program, it's new to you, right? You're trying to figure out how it works, what it does. One of the most valuable things to do is to look inside the program and find the very first instruction. Because as you step through one instruction after the next from the beginning of when the program runs, you can really start to grasp how the program works, the logic inside it. And so knowing that there is in fact a first instruction and knowing where to look for it is really valuable. All right, let's move on to the second of the 5 fundamental elements of any computer program. It's a thing called variables. Variables are just pieces of data that your computer program is going to work with, and it's data that can change while the program is running. Like if you're playing a video game, you probably have a score, and your score obviously can change while you're playing, right? Or if you've got a program that keeps track of financial transactions, obviously those can change while you're running the computer program. So you need variables to keep track of this information. If programs didn't have variables, then they can only work with data that was pre-entered into it. And the program would be of limited use to human beings. And we're making these programs to be of use to people, to provide help. All right. Third element of a computer program is what is called control and branching. This is a way to put instructions into the program that can control whether or not one of 2 or more possible courses of action happen. In other words, have the computer make a decision. And you're going to see all this when we write code today. But I'm sure you can see that this is a pretty valuable thing for any program. If you're not able within the program to have it look at data and make a decision based on that data, well, your program isn't going to be very helpful. And so you need control and branching. Branches are those 2 or more possible things that can occur. That's what a branch is. The fourth fundamental element of any program is actually really cool. Well, I think it is, but admittedly, I'm a nerd, okay? It's what's called a subprogram. And a subprogram is really a program within a program. And the way this came about was 60, 70 years ago when the first programmers were figuring out these computers and making instructions in them, making big, long programs, one instruction after the other. They started to realize that they had a problem. The problem was that often when writing a big program, there was a certain a certain sequence of instructions where all the steps were identical. Maybe there's 5 things that you do in order, and you would end up doing that 20 or 30 or 50 different times throughout a big program. Literally identical 5 steps as an example. And not only did that get, boring to type out each time, but also is very prone to error. You'd have to get it exactly the same way every single time. And worse yet, if something about the way those 5 steps changed in the future, you would have to go back to your program and find every single spot that you put those 5 exact identical steps and change it in every single location. So very rapidly, programmers said, this is not smart. Why don't we take those? Again, it's just an example. It's not always 5 instructions. Let's take those instructions that we're using over and over again in our program and pull them off to the side and give this whole set of instructions a name. And we call this thing a subprogram. And that way, when you're writing your main program, every time you need that set of instructions to occur, you just call on it and say, hey, go do these things. And when you're done, come back and pick up where you left off. That's what a subprogram. And again, you're going to build these tonight in your code. Super valuable part of a computer program. And finally, the last element of any computer program is an exit. There needs to be a final instruction. Again, that's almost might seem pretty simple, right? Because eventually a program has to end. It's got to stop, right? Even if it's just you clicking on a little X, that will trigger the final instruction. Now, why is that important? Well, remember what we did at the beginning when we turned on the computer program. The computer reserved a bunch of memory locations for our computer to use. And if we don't unreserve those, then it just means less memory locations available for every other computer. And so when your program hits this exit instruction, this exit point, it tells the computer underneath, hey, you don't have to reserve all those memory locations anymore. And it helps your computer perform more efficiently. All right. So those are the 5 fundamental elements of any computer program, no matter what the language, you will find that these and only these things are used in making a computer program. Now, they're not in this exact order. Obviously, you have to start with the entrance point and you have to end with the exit point. But inside there, they're in all different order based on what you're trying to get done. All right, so we're going to write some code. And to do that, we need a code editor, a place to enter those instructions. So, Gracie, if you could drop into chat the link that you see here, I'd like everybody to click on that link in chat. And I will do so as well. This is what you're going to see. Now, don't worry about all these words and instructions inside here. We're going to get rid of those anyway, okay? But what you're looking at is a code editor. You type your code on the left over here, and any output that your program makes happens over here on the right. Now, let's go back to the slide. This part is important. I want you to be able to have what I'm writing and what you're writing side by side. It makes it a lot easier. Now, if you have two monitors, that's pretty simple. Put me on one of them and your code editor on the other. But if you don't, then set it up like this, with me on the left of your screen and your code editor, that browser tab that you just opened, on the right. If you need any help with that, and by the way, what you're doing when I say me on the left, it means your Zoom application. That needs to be on the left. And here's a little bit of, advice on that. If your Zoom application is being troublesome and doesn't want to resize and move around, you can click on the words that say Zoom meeting and then restore, and it'll make your window smaller and you can move it around as needed. And for the browser, same thing. If you look in the top right, there's a little symbol with two squares. When you click on that, it can kind of make it smaller and easier to move around. So that's why I'm going to give you a second while I take a sip of water to get set up with me on the left and you on the right. All right. So now let's write some code. First thing I'm going to do is I'm going to show you the computer program we're building. You'll get access to all the code you see on the screen at the end of the class. For right now, you all aren't going to do this. I'm just going to put the code in there and I'm going to run it. And you can see it's a blackjack game. You want to hit 21 or as close to 21 as possible, but don't go over. I'm all in. I'm just going to say I'm betting 10 chips. So, ooh, that's not a good hand. Got a queen of clubs, 3 of hearts, it's 13. The dealer's got 9. That is really not good. But I'm going to have him hit me. Give me another card. Oh, I busted. I get another queen, and I went to 23. All right, good. So, this is the game, okay? Now, we're not going to build this entire game. I just want to show you something. If we were to look through all this code here, we'd be here about 3 hours or so, or longer, building all of this. And frankly, it wouldn't help you learn very well. What we've learned over time in helping thousands of people break into tech is that it starts with the fundamentals. So what we're going to do is this. We're going to get familiar with Python by using it to implement those 5 basic elements that we just talked about. And in so doing, you're going to learn a lot about the fundamental key data of programming. So let's start with just a simple instruction, which will be the first instruction that gets performed. And we're just going to make some text appear over here on the right. And that's done with a Python instruction called print. So all lowercase, just type P-R-I-N-T. Do not hit the space bar. When you're done with that, give me some open and close parentheses. This code editor will automatically create the closed parentheses for you as soon as you hit the open one, which is kind of nice. And then let's do double quotes. Say, hello, fellow kids. There's a meme I haven't seen in a while. All right. Now, we're going to run this, see what it does, and then we're going to break down how it works. Because even though it looks really simple, or it might, there's some really valuable information here. So this little symbol up here, the play button, the triangle, click that. And this is the output you should get on the right. Hello, fellow kids. Let me see if I can make this a little bigger. There we go. Okay, I like that. Pop into chat a 1 if this is readable, or a 2 if it's too small, or there's a problem. Give me a 1 if it's good, and a 2 if it isn't. All right, a bunch of 1s. Okay, good. All right, now, again, this is a fairly simple thing, but I want to explain a couple key pieces of data here. The first one is, how is it that this Python language knows what to do? We're all looking at this word called print. And to us, well, it kind of makes sense that it would put something on the screen. But I want to share with you how Python actually works. You see, Python has built into it a huge set of words that are its built-in instructions. Things like print and if and else, and there's several of them. And we're going to encounter several of them tonight. There's these built-in instructions. These are words that basically belong to the Python language. You're not allowed to use them for your own purposes. They mean something precise in the Python language. So let's pretend you're a computer and you can only do one thing at a time. Here's actually what you're going to do. This is actually what happens when we hit run. The Python program looks at the first letter, P, and it looks inside its list of instructions and says, is there an instruction that matches this called P? And there isn't. And so it says, all right, let me move on. It looks at the next letter, which is PR. Is there an instruction or anything else I'm keeping track of that matches this PR? And there isn't. So it keeps on all the way till it gets to these. Now it's looking at all 5 of these letters. Now remember, Python can't think. No computer can think. Python doesn't understand the concept of printing something. It's just got a list of instructions, and it looks through these characters one at a time, and now it's found a set of 5 characters that matches one of its instructions. And it knows what to do now. It goes, oh, well, this instruction that I have programmed into me, this print, the very next thing that's supposed to be there is a parentheses. And so it goes forward. It goes, oh, there is. Okay, good. And then watch this. It says, what I'm supposed to look for next is a closing parentheses. And so it reads all the way through this information and goes, I don't care about this. This isn't a parentheses. And it goes, oh, look at that. There's a closed parentheses. It says, all right, now what I need to do. Now, I'm taking a long time to explain this. The computer does it in like 1/1,000,000th of a second. Okay. What the Python program does now, it goes, okay, so I know where the open parentheses is over here. I know where the closed parentheses is. And what I'm being told to do is to look at everything between those 2 symbols. And that is what I'm going to put on the screen. So then it goes back here. It says, okay, well, the first thing is a double quote. Oh, that's right. It says in my instructions that if you encounter a double quote or a single quote, that's not supposed to go on the screen. What you're supposed to do is look forward and see if you find a matching one. And oh, it finds one. Okay, good. Now we're narrowing in. The print command just wants to find what's the exact thing I need to print on the screen. And it does it by matching up these patterns that are built into the language. So now it knows where the first and the last double quotes are, And then it can go back here and grab all this information and put that on the screen. This is how a computer works. It does one thing at a time. Your computer may operate very, very quickly and look like it's doing multiple things at once. But I can assure you, and you'll learn all about this on our boot camps, on a physical level, computers cannot do two things at once. It can do a lot of things one after the other very, very fast, but it can only do one thing at a time. So that's literally what it does. It starts at the beginning, goes through one character at a time until it identifies, oh, I know what this is. And then based on what it is, it's got some rules that say what's supposed to come after. And it's all programmed into the Python language. Now, you don't need to memorize any of that. In fact, you don't even memorize the print command. You can look that kind of stuff up, but it's trying to teach you a little bit about how the computer thinks. Now, any questions so far? I'm going to look at chat for a second. Anybody have any questions? All right, let's step back a little bit because that was really nerdy. We're going one character at a time. Okay, here's a little bit of a bigger picture. A lot of the instructions in Python, and print is an instruction. A lot of the instructions in Python, in order to do their job, they need to be given some information first. And in Python, the way you do that is immediately following the instruction that needs information, you put parentheses and the information goes inside. You're going to see that pattern over and over as we go through our code tonight. And in fact, you're going to make your own instruction, and it also will use these open and close parentheses. And inside, if needed, is where you put the information that your instruction needs. We're going to build your own instruction, which is cool. All right, so that's one instruction. Now, it happens to be the first one that's executed, okay? So let's go on to the other thing, which was variables. Now, Python, the language, was made to be really friendly, and it makes it very easy to create variables. All you really need to do is come up with a name for the variable. Now, let's talk about the concept first before we get into the nerdiness. The concept of a variable is this. You've got a bucket. On the outside of the bucket is a unique name. And inside the bucket is the actual data that you care about. What does that look like inside a computer? Because computers aren't made of buckets. Well, remember that device I talked about called a memory storage device, or RAM? It's composed of millions or even billions of individual little locations, physical spots in that device where you can store information. And so when you make a variable, what you're doing is you're choosing one of those locations and you're giving that location a name. After that, you put information in the location. So let's do that. Let's choose a name. Now we're building up to look at a blackjack game. So let's do one called player score. Type it exactly the way I did it. Lowercase Player, uppercase S, lowercase core. Now, this is all you need to do in Python to make a variable. But can anyone tell me a name that you're not allowed to use for a variable? Drop it in chat if you can think of a name you cannot use for a variable. Ooh, two really good answers. I like this. First of all, print. You can't use print. That's a reserved word. It's reserved for the Python language. If Python reads print, remember, it goes, oh, I know what that is. That's a built-in instruction. So you're not allowed to use it. Another one, Andre had a great one. He said you cannot use this. Oh, wait. As a variable name, the space. You're absolutely right. It needs to be one set of characters without a space, because Python will read this And when it gets to the end of the R and finds a space, it thinks it's done reading the data. And so it goes, do I have an instruction called player? No. All right. Then I guess you're making a variable called player. So that was a really great point, Andre. This is how you write it. All one set of characters, no spaces. So we've made a variable. Now, all that really equates to is we've got a bucket with a name on the outside. What's missing? Put in the chat if you know what's missing. Let's see if I get the name right. Talisha, you're right. Give me the concept of what's missing. You're absolutely right for the syntax. Same with you, Matthew. Okay. Give me conceptually. Ooh, a couple really good answers here. Conceptually, what's missing is the data that's supposed to be stored inside the variable. That's what's missing. So there was a bunch of really good answers here, including one that I want to talk about a little bit. First of all, we're going to finish this, and then we'll talk about Yashish's answer, which was Yashish had a great answer. What's missing is giving a value to this variable. In other words, what's stored in the bucket. And you do that with a special symbol for Python. It's a Python symbol that is the equals symbol. And then after that, we put the data we want to be stored in the variable. Let's say it's 21 because the player is going to win. Now, again, this is a word, a symbol, and a number. But there's actually some important things going on here. And if you're trying to teach yourself to code or follow any online resources or whatever, and you're not quite certain of what I'm about to go over, and I've done this myself, you can get confused very, very quickly. So follow me closely here if you would. There's two words to learn here because there's two specific different things that occur one after the other. The first word is called declare. It's a verb. When we type in this player score, we are declaring a variable. That's the official Python term for it. And that's a common term in lots of programming languages. All it really means is you're designating a specific location in memory with a unique name. This symbol has a specific name. It's called an assignment operator. Assignment is the verb. Assignment means to actually give the data that will be stored in the variable. And an operator is something that makes the computer do something. So we're making the computer store this information, which is called the value, in the variable. So the way you would say it is, we are declaring a variable player score, and we are assigning that variable the value 21. We're declaring a variable, we're assigning it a value, and the value is 21. That's the terminology. And it's just important to realize there's two things that are happening there. First, we declare the variable, and then we assign it a value. Okay, good. All right, now, really great comment from Yashish. I was asking, what's missing? And before, what was missing was this part right here, right? But their answer was the type of variable. Now, let's talk about that. There's different kinds of data you can work with in a program. And by the way, never heard it before? The purpose of a computer is to take in data, process that data in some way, and then send the data on. That's the entire purpose of a computer. Well, there's lots of different kinds of data. There's numeric data, there's text data, There's date data. So when Yashish quite intelligently said what's missing is the type of the variable, what they're referring to is we have a variable player score. What type of information is going to be stored in there? Now, we can look at this and we can tell that it's numeric data because we've assigned the variable a numeric value. And here's something that's kind of interesting about Python. Unlike some other languages, you don't specify the type of information that's going in the variable. The language figures it out from context. It's programmed to do so. That fellow, Guido van Rossum, who made the language, said, I don't want to deal with that. In many other languages, you might have to do something like this. You'd have to type integer before the variable. And this would be part of the language. It's not part of the Python language, but it is for other languages, right? This would be a part of the language that says, hey, I'm about to make a variable, and the type of data that's going to be stored in it is integer data. Okay, good. Here's the name of the variable. Okay, good. And here is some integer data. Good. So in Python, you don't need to do that. You just say the name of the variable, declare the variable, and assign it a value. And the Python language figures out what type of data it is. So it's just a thing to know, a little bit more advanced, but Yashish brought it up, which is awesome. It's a great thing to bring up. All right, so we made a variable. Now, let's use that variable. First of all, let's go back up here above the player score variable. Let's say we wanted to print out on the screen that the player's score was 21. Let's do that. Let's type print, and then you got your open and close parentheses, and you got double quotes, and then say the player's score is 21. I'll leave that there. When you've got it ready, go ahead and run it. Well, that's cool if the player's score is 21, but it's going to be all kinds of numbers, isn't it? Okay. What we want to do is we do want to print the player's score is, but we want this part to be, are you ready for it? Variable. We want it to reflect the actual current score of the player. So how do we do that? Well, let's do the same thing. Let's do print the player's score is. Now watch. Hit a space and go right after the double quote. Yes, Matthew, there's other ways to do this. I'm going to show them the simplest one. Go after the double quote, hit a space, and now we're going to use another really cool Python instruction or a symbol, which is the plus symbol. Now, we all know plus from math when we were like 6, 7, 8 years old. This is not that symbol. This symbol, because it's after some text information, means take the text information on the left, which is this, and add it to what's on the right. In other words, stick them together. There's a nerdy word for that. It's called concatenation, which even now, after decades, I can't say without sounding obnoxious. Concatenation. It just means sticking two pieces of text together. That's all it means. So we don't have text, but we have this. We have a value inside a variable. What happens if we use the variable here? Make sure you type it out exactly the way you wrote the variable. PLA, let me make this a little wider. Capital S, Run this. Ooh. Did this on purpose. We get to talk about a couple of cool things. And by the way, Yashish, this is your fault because you had that really good observation, but it's a great teaching moment. So we got an error. Give me a 1 in chat if you got the same error. All right. Now, why did we get an error? Well, it's because this symbol, like I said, is supposed to be a concatenate. It's supposed to connect 2 pieces of text. Well, we've got text on the left, but what's on the right? It's a number. It's like saying, how old are you? Or no, that's like saying 5 plus Wednesday. That doesn't make any sense, right? And that's what's happened here. So Python figured out that this variable player score is holding data that's numeric data. And that's not going to work for us. What we need to do is we need to turn that numeric data into text data. And look, the error tells us how to do it. It says right at the bottom, can only concatenate str or a string to a string, not an integer. That's what this means. So let's turn this into a string. Now, I don't memorize syntax, and you shouldn't either. So let's have some fun here and use our friend and go, how do I convert a number to a string in Python? Ooh, look at that. It's got a function called str. So look, we have the same thing. They have a variable called num and give it a value of 42. You put str and then you put the variable inside. Oh, okay, let's do that. So look where my cursor is. It's right before the variable player score. Let's type str, do an open parentheses, and then go all the way to the end and do another close parentheses. And that should turn the 21 into the 2 text characters 2 and 1. It's no longer a number. So let's run this and see if that works. Oh, I missed a parentheses. Oh, the editor didn't do it for me because the editor does some funky stuff. All right, so make sure there's 2 parentheses at the end. Run it. Look at that, it worked. This is text information. That was really good. All right, excellent. Any questions so far? Okay, so here's the thing I want to point out. When the score changes, now the message will change. So let's change the score. Type out your variable again, player score, and make it equal 23. And then you can type it out if you want to. I'm going to copy this whole line and paste it down here. I recommend you do too, just in the interest of time. And we run it. Now look at that. We are successfully keeping track of data that can change while the computer program runs. In other words, we're using variables for their purpose. Of course, someone's score is going to change. It's going to change every single time there's a turn in this blackjack game. And we do need to display that information on the screen, so we absolutely have to have a variable that keeps track of the score. And when we do this print, we're showing that we can make use of that variable. Same exact instruction. So let's move on to control and branching. And by the way, adding in an extra blank space like I did here on line 7 doesn't do anything to the program. It doesn't change how it works. It just can make things a little more readable. So let's talk about another situation. At the end of each turn, we have to figure out whether or not the player went over 21, don't we? If they went over 21, then they lose. Without getting all the nerdy logic and statistics revolving around the game of blackjack, that's a pretty basic rule. If your score goes over 21, you lose. So that sure seems like we have two different courses of action. We'll do one thing if the score is not over 21. And we'll do another thing if the score is over 21. That's control and branching. So let's do the control first. In a control instruction, you give the computer some information to look at to make a decision. Here's the most common control instruction in Python. It's called if. So write it, but don't put a space after. Here's how this works. Do an open and close parentheses. Now, clearly, because we have a Python instruction followed by some open and close parentheses, this instruction needs some information in order to do its job. Just like the print instruction. Here's the print, and inside the parentheses, it needs the information that it needs to do its job. Well, what kind of information does an if need? It needs what's called a condition. Technically, if you get it really nerdy, they call it an expression. In other words, it's something the computer can look at and determine whether or not it's true. That's all. Let's put something inside there that compares two different pieces of data and see whether the comparison is true or false. What do we want to compare? Well, we want to compare the current score and see if it's greater than 21. So we're going to use the variable player score. And then we're going to use a special symbol, which is it's a comparison symbol. It's this angle. You'll find it just to the left of your shift key. It means greater than. You probably remember that from math back in school, right? And hit a space and then do a 21. Now, this reads almost like English. You can kind of understand it. We're saying, well, if the current score is above 21, then we're going to do something. This symbol is a Python symbol. This greater than symbol. It's called a comparison operator. This symbol was an assignment operator. It's just the different kind of parts of the Python language to get used to. This symbol I've got highlighted now, the assignment operator, puts a value into a variable. This operator, called a comparison operator, compares two things to see whether or not it's true. Well, in this case, player score, last time we were with it, was 23. So it is greater than 21. So what do we want to have happen? Now, in the actual game code that you're going to get later, there's a lot more nerdy kind of detail to this, but we're going to make it real simple. If the score is over 21, we're just going to print out, sorry, you lose. And if it's less than 20, if it isn't greater than 21, we're going to print out, you're still in the game. Again, there's a lot more complicated logic in the actual code we're going to give you, but we're going to keep it simple just to show you how this control and branching works. So right now we have a control instruction. The if is a control instruction. We've given it some data to look at, which is either going to be true or false. There's no in between. Now we need to lay down, what do we do if it's true? And what do we do if it isn't? Those are our branches. We hit a fork in the road with the if instruction. We've got to decide what to do if the condition is true. So the way you do that in Python, and this part's really, really vital. You put a colon at the end of the line where the instruction is. Don't hit enter or anything. I want to tell you what we're going to do next. We're going to put one or more instructions below here, and we need a way to mark off the instructions so that the Python language knows that they are only to be performed if this condition is true. And the way we do that is by indenting the instructions. It can be 2 spaces or 3 or 4. That's a bunch of nerdiness you don't need to get into. But if you indent them and you indent them all to the same level, then they're all grouped together under a branch. In other words, they're only going to be performed, like I said, if this is true. So watch what our editor does. Go to the end of the line and hit enter. And this editor is really friendly. It's built for Python. So it automatically indents 2 spaces, which is helpful until you forget that you're indented and you don't want to be. So what do we want to do if the condition is true? We want to print, P-R-I-N-T, don't forget your parentheses, and then a quote, sorry, you lose. Now let's run this, because it should say sorry you lose because player score is currently 23. Look at that. Sorry you lose. Give me a yes or no. Did anybody get an error when they ran that? Yes or no? Drop that in chat. No error. No. Okay, good. Excellent. Now, we've only taken care of one possibility, though. What do we do if this condition isn't true? Well, the way you do that is you use an instruction that matches the if. It's called an else instruction. Now, go to the end of this line that says, sorry, you lose. Hit enter. And this part is so important. When I was learning Python, this messed me up so badly. I'm indented right now. If I start writing an instruction right now, it's in that set of instructions that's only going to happen if the condition's true. And that's not where I want to be. So I have to backspace so I'm no longer indented. If you forget that, your code behaves all kind of weird and you can't figure it out. Not that I've ever done that. So here's the instruction that matches the if. It's called else. That's all. This is the second branch. The first branch, which comes after the colon, is this instruction. And if there were any other things we wanted to do, we could put them below this. And as long as they were indented 2 spaces, they'd be included in what do we do if the condition's true. But now we've got an else. This is what do we do otherwise? And because it's a control instruction, you put a colon at the end, hit enter, and look, the editor is friendly. It automatically indented us because now we need to put down the instructions that will only happen if this condition is false. Sorry, this condition right here. Well, what do we want to do? What do we want to do? We want to print, you're still in the game. So print, you are still in the game. Let's give it a nice exclamation point to be friendly. So let me ask you all a question. Make sure you go to the end and backspace. If we make player score, I might want to spell my variable correctly, equal to 8. What's going to get printed to the screen? Give me your guesses in chat. If I run this code, don't run it. Don't cheat. If I run this, what's going to get printed to the screen? Ryan says you lose, which is correct. Matthew says you're still in the game, which isn't. Sorry you lose. Sorry you lose. Okay, so. Well, first, we, of course, are going to print hello, fellow kids. Then we're going to print the player score is 21. Then we're going to print the player's score is. And this is the important point. We've changed the score here. So now it's different. Because these instructions run from the top to the bottom. At the time we perform this instruction, the value of player's score at that instant is 23. So when we run this if, player score is still 23. Only later, after these instructions have run, do we change player score. So if you run it, it still just does the same thing. Okay, good. So it does, in fact, run the equals 8, Matthew. It just doesn't do anything with it. It changes the value. Now, we are looking right at the reason that subprograms are so valuable. The score just changed. And the program has to make a decision. Did the player win? Or is the player still, is the player still in the game, or did they lose? We have to make a decision. Now, I realize I'm greatly simplifying the game, okay? But the score just changed. We have to make this decision again. Now, I don't know about you, but I don't like the idea of copying the code and then pasting it down below and then running it again, and it says you're still in the game. I'm going to copy this code over and over and over and over in my game? No, not at all. So if you did what I just did, then Control Z and make it go away, because we don't really want that. Okay, good. What we want, instead of having to type those 4 instructions over and over again, is we want a little subprogram that we can do the same thing whenever we want to with only 1 line of code. We need a subprogram. Now in Python, they call them functions. So we're going to make a function. The way you do that in Python is you use the instruction def. It means define. We're about to define a function. Now remember that I was talking about this early on. I was talking about the early history of computer programming and how people were repeating the same set of instructions over and over again, and they took them off and they separated them to the side and they gave that set of instructions a name. That's what we're going to do. We have to have a name. And it should be a name that kind of describes what kind of work we're going to do. We're going to check if the game's over. So I'm going to call this function check game over. You don't have to capital. No, let me clarify. You've got to type it the way I typed it, or your program is going to be a real pain. But there's no rule about how I typed it. I could have check capitalized as well. It's just there's conventions and usual ways of doing things. And so this is called camel case for those of you who are interested. Instead of uppercase, it's called camel case. So that's the name of my function. Now, can anybody tell me what I should type next and why? Either you came into the class already knowing this, or if you didn't, you were paying attention earlier. What's the very next thing I need to type and why? Okay, Sabita, you got it right. Sabita, I'd like you to type into chat, if you don't mind, why you think that that's true, because it is true. Sabita said it's a parenthesis. Why? Talisha got a good answer as well. I'll jump on that just in interest of time. Okay. Not that you were probably going to get right, Sabita. Talisha said to pass an input. We're making a function, in other words, a subprogram, and it might need to take in information in order to do its job. So the way Python is set up, you have to put, here it is. Oh, well, I'm not over there to type. You have to put it an open and close parentheses after you say the name of your function. Sabita, you nailed it. Sabita said, because it is a function and it might need input from outside. I actually love the way you said that. It is spot on. So tell me in chat what information needs to go into this function we're making that's called check game over. What information we need to pass into it when we want it to do its job? Give me your ideas in chat. Player score, baby. Absolutely. Computer score as well. Yeah, I didn't want to make it too complex, Matthew. We're just going to illustrate that you could have a set of instructions like this that would happen over and over again, and you could turn them into a function. But you're right. In the actual game, it's a little more complex because you have to check your score, the player. You have to check the computer score. There's some more logic to it. But so several people got this. Is absolutely right. Player score goes in here. Now, failure to understand this next thing has led to more headaches and your hair tearing out and confusion than almost anything, not just in Python, but in learning any programming language. So please, if you pay as close attention as you can to this next thing. We're not going to type anything. I'm just going to talk for a second. When you're making one of these things called a subprogram, right? And in different programming languages, they have different names. You might call them a subroutine, a method, a function. It's all the same thing. What you're doing is you're defining some potential work that could occur in the future, but only when requested. And that tiny thing is so critical. We're about to lay down some instructions on what to do whenever we need to check whether or not the game's over. You know what the instructions are. We kind of have them right here. We've already done this. You're about to lay down those instructions. But the point that can get very confusing if you haven't got these two things separated out is this. The instructions we're about to type are absolutely not going to be performed when we run the program. Even though you're going to put instructions in, they're not going to happen, and I'll show you. So first of all, let's get the instructions. At the end of this line, you see where my cursor is, it's blinking. Do a colon, and notice when you hit enter, we get indented. Why? Because what we're going to lay down now is what are the instructions to happen when we call upon this function called check game over. And these are the instructions. We've already done them. We're going to print, we're going to check if player score is greater than 21. And then we're going to, if it is, print, sorry, I'm going to say, buddy, you lose. I'm being a little more aggressive. And then I'm going to go back and do an else. And then we're going to, if it isn't greater than 21, we're going to print. So you're saying there's a chance. Like that. From one of the best movies ever made, Dumb and Dumber. So you're saying there's a chance. So these are the instructions that we want to have happen whenever we want to check if the game's over. So don't run the program yet. I'd like you to guess in chat, what's the final message that's going to be over here on the right? What's the last thing that's going to be printed on the right when we run this code? Take a guess. Tabitha says, so you're saying there's a chance? Talisha says you're still in the game. Someone says, sorry, you lose. Sabita says, because player, okay, good. Thank you all. Okay, now, again, don't run it yet. I just want to talk about this. It's actually a really important thing. And I'm not saying that because, oh, I know so much. I'm saying that because I messed it up so much when I was trying to learn. So this is the reasoning that I saw in a few of the chat answers. And thank you all for being so involved. I appreciate this. Now watch this. Remember that you're a computer and you're going to do one thing at a time. So we're going to do one instruction at a time. We'll do this instruction. That's really simple. Okay, good. We're printing. Then we'll do this one right here. Okay. Then we'll make a variable. Let's just start paying attention to the value of this variable. Well, right now, the variable's value is 21. So then we print, and it ends up saying 21. Now we change the value to 23. The value's 23 now. So then when we do the print, it says 23. You can see that over here. And then we do this if. Now, at the time we're running this, player score is 23. That's greater than 21, so it says, sorry, you lose. Why did it do that? Okay, good. I didn't run it. Okay, good. So it says, sorry, you lose. So here's the question is, now we change player score to 8. Why didn't it print, so you're saying there's a chance? I know a few of you thought that it might. Here's why. This set of code doesn't do any work. It's not executed. All these instructions do is they define a set of instructions that could happen later if you ask them to occur. That's all that's happening. So, how do we make them occur? How do we make this check game over function, which contains these wonderful 4 instructions with my obnoxious answers? How do we make those instructions run? Well, go to the very end of your code, way down at the bottom, and hit enter. Make sure you hit backspace so you don't stay indented. Make sure you're all the way to the left. We have to do what's called, or what's referred to as, calling the function. That means saying, hey, Mr. Game Over, Mr. Potential Work, you're sitting there saying, hey, I'm over here ready to do some work if you want me to, but you've got to ask. The way you ask is just by typing out the name of the function. So we say check, make sure you spell it exactly right, game over. You put your parentheses, and inside here, you put some data. Now, watch what I'm going to do. I'm going to pretend. Well, no, I'm not. I'm going to pass in this variable, player score. And that's it. We are now finally calling upon this potential work that we defined. When you say you're defining a function, you're defining work that could happen. Now we're actually making it happen. So if we run this, Now it says, so you're saying there's a chance. Now watch this. Do we have to put the variable player score in there? I can give it any data I want. I can give it 2. And I can run the code. And it'll say, so you're saying there's a chance? I can give it 25. And I can run it. And it'll say, sorry, buddy, you lose. The point is, you can put any data you want to in this. Now, we're going to pass in a variable, but I just want to show you that as long as it's number data, as long as it's numeric, which is what we need inside here, it'll work. Any questions about that? All right, now, let's move to here. Gracie, can you drop this link? Well, I've got it right now. I'm just going to drop it. It's right here in front of me. All right. I'm going to say to everyone and grab that link and grab this code right here. And do a Control A to select it all. Do a Control C to copy it all. Come over here to your code editor. Control A and delete everything. And then paste it all in. Paste in all that code that you just got from that document we gave you. And then run it. And I'm going to give you all a minute to play the game. And then we're going to look through the code a little bit and see that a lot of it is going to be familiar now. So I have 10 chips. So I'm going to bet 5. Oh, 10 and the queen. Oh, I'm going to stand, man. No way. I got a 4. Dealer wins. Oh, man. I don't. All right. I'm going to put it all on the line. 5 chips. 13. All right. Hit me. Ooh, I'm at 16. And they're at Queen of Diamonds. I'm going to stand. Ah, man. I lost. Okay, good. Okay. All right, so let's look at this code a little bit. Now, just in the interest of time and the fact that it would open up a whole nother set of like questions, we're not going to go through every single thing. I just want to show you that those 5 elements are present. Let's talk about variables, okay? Oh, here's an instruction you haven't seen before. It's called import. A module is a set of pre-made Python code. There happens to be a module out there called random, and it helps you in generating random numbers, which is pretty valuable when you're making a card game. So we're going to bring in this module, this pre-made code called random. And now, oh, look, we're defining a function. You can tell it's defining a function called create deck. We're defining a function called card value. Another one called the hand value, calculates the total value of hand. These hash marks and everything after it, that's a comment. That's just for you to understand the code. It doesn't get performed. It's not an instruction. Then there's a function called get valid bet. Oh, this is another control statement. And there's a code branch. You can see a bunch of ifs, some else ifs, some else. Oh, okay. You can look up a lot of this stuff and kind of like follow along with what's going on. Here's another function. Here's another function. Look, here's a variable. There's a variable called chips. We initialized it and we set the value to 10. Okay, good. All right. And look at that. While chips is greater than 0. In other words, while the player still has some chips, they can keep playing. You can follow along with the logic here, right? And we're still inside this function. This function, by the way, is called play game. And it's a big function. And then finally at the bottom, we actually call the function called play game. As soon as we call play game, then this function starts to run. We set the number of chips. We run the function called getValidBet. We create a deck. Yeah, okay. You can follow along with some of it. If you go through our boot camps, you would be able to understand every single bit of it, program this, and much more complex applications. All right, so I just want to kind of give you a little bit of tour. You've got the code now, okay? Let's get back here. All right, can you see the slide that says split screen? Let me know in chat if you can see that. Okay, good. Thanks, Alicia. Okay. We've done our coding. I tried to leave all the questions. Just in the interest of time, because we went a little long, I'm not going to do any more Q&A. You're going to have a chance to email us if you want to. If you have further questions that didn't get answered, you can send them in the email. They always get forwarded to me, and I always respond. Okay, so let's talk about the school, like who we are. And by the way, stick around because we have a really cool free gift. This won't take very long, but it's pretty important. I'll say this, for the right person, this is probably pretty important data. We have 12 different boot camps covering a huge range of technology subjects. You can see them on the screen, like anything from artificial intelligence to computer programming, website development, cybersecurity, design, data science, video game development, mobile app development. In fact, we have more certification programs than any other coding bootcamp on earth. But it's how we run those that I'd like to call to your attention. The way we run our boot camps is a little different. First of all, they're self-paced. Not everybody moves at the same pace when they learn, and we accommodate that. But they're also instructor supported. They're flexible. You set your own study schedule. The content on them is really well-rounded and in-depth. They're affordable, priced under the national average. All of the boot camps include job placement training and job placement assistance. But most importantly, they're all designed for absolute beginners. No technology knowledge or coding experience is required. So you don't have to be a nerd. I do say some nerdy things in some of the curriculum videos, so you might understand more of my stupidness, but you don't have to be a nerd, okay? And so who are our programs for? They're for anyone looking for a better career. Technology is a great industry to work in. There's remote work opportunities. There's a great work-life balance, and it pays really well. We consistently land on every major best coding bootcamp list there is. Our average review rating across all major bootcamp review websites is 4.8 out of 5 stars. We're really proud of that. It's based on student and graduate feedback. So here's a question for you is, why would you consider working in tech? And I know not everybody who comes to these classes is 100% like, I really want to work in technology. That's fine. But consider, why would you? Well, technology actually has really good work-life balance and has a lot of possibility for remote work, especially now post-COVID. Also, it's a really creative industry, and it's one that you can take a lot of personal pride in your work in. It's also a stable industry that pays really well, and as you advance and learn more, take on more responsibility, there's regular increases in pay, and the pay ceiling is a lot higher than a lot of other industries in the world. That said, there are barriers to doing a boot camp. I freely admit that. One of them is the money. It costs thousands of dollars in tuition to go to a boot camp, right? And we've attempted to handle that by providing multiple financing options, including a huge upfront discount, also a monthly payment option for people that don't have great credit. In fact, there's an option for everyone. The fact is, though, that getting through a boot camp is an investment in yourself. You're giving yourself skills that are super in demand because it's work that's difficult to understand for people, it's hard to do, and they really need it. Another barrier to getting through a boot camp is time. There's a lot to learn. Some boot camps out there attempt to solve this by running their classes in cohorts. That is, everybody starts on the same day, and they all move through the curriculum at the same rate. People don't learn like that, and you can fall behind really easy, and it sucks. Also, some places make you come in person to study. All of our boot camps are online, and you set your own study schedule because they're self-paced boot camps. which means part-time studies allowed. So you can study concurrently to holding down a job, which is really cool. Finally, one of the barriers to get into a boot camp is the fact that you'll have to have some technical interest or ability. Now, I said earlier, and it's true, that our programs are designed for people that have no prior technology or coding experience. I know that a lot of people I talk to who aren't in tech but are interested in it have sometimes taken losses on trying to study online curriculum, books, videos, tutorials, and it's just they could not get it. And they started to maybe even feel like there was something wrong with them. And I assure you, it's not you. Some educators assume too much prior knowledge on the part of the student. They don't know what the actual fundamentals are to study. And through hard work over a decade, we've identified those. So you don't have to be a nerd to get through our programs. You don't have to have any technical background to enroll. So I've got a question for you. A couple of questions, really. Are you working a dead-end job? And I don't mean that like in an insulting way. I just mean that it's not really going to meet your needs. Maybe not in the short term, but certainly not the long term. Like, look around at the people that get paid the most in your industry. Is that enough for you to work hard for 5-10 years and have that be the cap? Or maybe you're even unemployed. Possibly you want to work from home, but you've got the kind of job that either physically can't even be done from home, or you're in an industry that just doesn't tolerate that, right? Maybe you want more time with your loved ones. The whole point is, ask yourself, is it time for a career change? And if it is, Tech Academy is the solution. We're career change experts. That bridge in our logo represents a route into technology for everyone. And we've got a decade now of experience of breaking people into tech. Most graduates make $30 an hour in their first job on average and go up from there as they get more experience. And we've got over 1,000 graduates working in tech at anywhere from small mom and pop companies, medium-sized businesses, to the big guys like Nike or Facebook, Disney, Epic Games, Uber. We've got people at all those companies. And so as a reminder, it's open enrollment. You can start anytime. And I encourage you to start now. Now, in the month of August, there's a few incentives if you sign up this month. First of all, you get a full 50% off tuition discount if you can pay up front. Also, if you're in America and you need a laptop, if you paid up front, we'll send you a refurbished laptop to get through the program. Also, for this month only, there's no sales tax. We'll pay the sales tax for you, no matter where you live. We'll also ship you a set of our coding books to help you get through the program, including, these are physical books we're going to send to your house. Our Intro to Coding book, the Computers and Technology Simplified book, our Technology Basics Dictionary, stuff that'll help you get through your program faster. You're not going to have to buy those. We'll send them to you. We'll also give you your own copy of our career planning guide that my co-founder and I put, it represents years of work. How do you plan? This book answers the question, how do you, the new person in technology, successfully, intelligently plan and execute the first 3 years on the job? And it lays out everything. First 6 months, first 18 months, first 36 months. Lays it all out for you, exactly what to do in what order. You'll also get 90 days of free access to what's called the Tech Academy Accelerator, which is a phenomenal subscription program that includes over 100 free courses, free training videos, and weekly workshops with me that are a super deep dive into topics suggested by the accelerator community to really help you accelerate your career. They're a lot of fun. They go way deep. Okay. And finally, this is something that we don't know when we're going to close this because it takes a lot of investment on our part. But if you sign up in August, you'll have unlimited job placement assistance until you land your first job. You got full access to all your curriculum, all of our job placement personnel, practice interviews, exercises, everything for as long as it takes for you to land your first job. So if you want to learn more, go to this link. If you could drop that link in chat, Gracie, that'd be awesome. There it is. Okay. And fill in that form. It's a simple form. But after the form is a series of steps all about the Tech Academy. They're really cool. It's videos and articles, and it just explains who we are, how the program works, what's on each boot camp, why the boot camp subjects are ordered the way they are. You'll have everything you need to make a decision. You can even book a call with our admissions folks from there. So complete those steps after the event, but I'm going to give people a moment who want to fill out that form. And I'm going to take a sip of water. By the way, if that link takes you to a login form, it just means you already have an account with us, and you can see the password you'll need at the bottom there. All right. Couple quick things, and we'll get you your gift. Our graduates love us, and so referrals have been a big source of enrollments for us for a long time. And so for a long time, we've offered a 5% commission payment for all enrollments. That's not just for graduates. In a moment, you're going to get an email address you can email in to get your free gift. If you have somebody who we should be talking to, who you feel like there's something here for them, give us their name and contact information. We'll keep track of that. And if they enroll, we'll send you a check right away for 5% of the tuition. I already mentioned books. I'll cover them briefly. We have 7 books, including 3 Learn Coding Basics in Hours books, a coding book for young kids and young adults, the Technology Basics Dictionary, the Project Management Handbook, and You Are Not Stupid, Computers and Technology Simplified, which is a phenomenal book. All right, here's your free gift. It is our Intro to Python book. Now, this is for people in the United States only, because we can't ship them overseas. I'm sorry. But if you're in the US and you'd like your own copy of this book sent to your house, just email us in. Gracie's going to drop the email in. There it is. Send us an email to that address asking for your free Python book, right? Please make sure you include your full name and mailing address. Every once in a while, someone forgets that, and it's really hard to send it to you if we don't have your address, right? Also, when you're sending that in, if there are questions that weren't answered, pop them into the email. We'll get to them, okay? And if you have any referrals, drop those in. I'm going to give people a minute if they want to send an email. I encourage you. It's a really good book. And it is easy to understand. I've got a good friend whose 12-year-old son learned to code with this book, not even the kids one that we wrote. He's 12 years old, and he got through this book and is actually writing his own programs. It's really cool. So it's great for adults, but like I say, even a 12-year-old got through it. All right. I mentioned links. Here's our Linktree link. I just happen to have it, so I'm going to drop it in for everyone, Gracie. If you click on that, you're going to see our Linktree, which is a collection of all of our links. Links to our free educational YouTube video playlist, links to our books and dictionary, links to our upcoming meetups. So if you want to come to another class, all the links are on there on Meetup, right? And all of our social media accounts. So please follow us on social media. And I just want to say thank you so much, right? For taking time out. I hope you got something out of this. I hope it helped, right? If you have any interest in finding out more, there's the link again, okay? And if you did fill out the form, please do the steps after the form. Find out for yourself what this thing is all about and whether it fits for you, okay? Thank you guys so much. Thank you, Matthew. Absolutely. Thank you all for the questions and the participation while we're doing the coding. That helps so much to get feedback and questions and answers to things. It was awesome. Absolutely. And Talisha, you're awesome. Great participation. It was great. Thanks, Tabita. You as well. And I know I'm probably mispronouncing your names. I apologize. All right. Have a great evening, folks, and we'll see you next time.